something that's very important to do, and a lot of students tend to trip up on this a little bit, is to distinguish between the sequence of the individual terms and the overall series. So let's think about what's going on here in this case where, in the example we just looked at in the previous video, where a sub n is 1 over n times n plus 1. So the sequence of individual terms is that should be 1/2, 1/6, 1/12, 1/20th, 1/30th, so on and so forth. While the sum is equal to, so this is going to be 1/2 plus 1/6 plus 1/12 plus 1/20th plus 1/30th plus dot dot dot. And so a lot of people kind of get these two things confused, but let's realize that these are different beasts. These are different objects. So this one is equal to 1 by, we saw that in the previous video. That's how we defined it. Well, this one, the limit as n goes to infinity of a sub n, it's not too hard to see that that's going to 0. So this sequence converges to 0. This series converges to 1. They're built up out of the same terms, they're built up out of the same building blocks, but they have different limits, and that's because they're different types of objects. So make sure when we're dealing with this kind of thing that we can distinguish between series and sequences. Okay, so here is a big theorem that will allow us to do calculations with series. It talks about linearity of infinite series, and it basically says that infinite series in these ways behave the way that we want them to behave. So if the sum of a sub n and sum of b sub n are two infinite series that converge, then the sum of where the individual terms are a sub n plus b sub n or a sub n minus b sub n, those both converge, and they converge to the appropriate things. The series where the terms are a sub n plus b sub n is the sum of the individual series. The difference here becomes this difference. And then if c is some constant, the sum of c times a sub n, you can just pull the constant outside the sum. So none of this should be all that surprising, and we will be using this through in future videos. To wrap this up, let's just do a couple of examples of series that diverge. We already saw one series that converged, the one that the telescoping series. Two divergent series. So one would be if we do the sum from n from 1 to infinity of 1. So that's 1 plus 1 plus 1 plus 1 plus 1 plus dot dot dot. So S sub n would be add up n copies of n, and that's just, n copies of 1, so that's just n. And so the limit as n goes to infinity of n is infinity, so this diverges. A different type of series that diverges goes in a different direction. The sum from n from 1 to infinity of minus 1 to the n. So this is going to be minus 1 plus 1, minus 1 plus 1, minus 1 plus 1, so on and so forth. So the sequence of partial sums goes minus 1, then minus 1 plus 1 is 0, minus 1 plus 1 minus 1 is minus 1, minus 1 plus 1 minus 1 plus 1 is 0, and it just goes back and forth here. So this diverges. Doesn't go off to infinity, but it diverges. So we say that this diverges as well. So that's a couple examples of series that diverges, and we'll be looking at a lot more examples throughout the rest of this set of videos.